Improving cooling system efficiency, Part 4, heat exchangers. As we've indicated in the previous section, the mechanical chiller consists of a condenser water section and a evaporator section. In the chiller condenser, where the water flows through the cooling tower, the process of evaporation at the cooling tower of water into the atmosphere tends to concentrate the minerals that are present in the water and can lead to mineral scale deposits on the water side of the chiller condenser. And if these should happen to form, they create an insulative barrier for heat transfer and can actually adversely affect the chiller efficiency by up to 5 to 10%. And also we need to know that the cooling tower itself, the tower fill must be maintained in a clean condition, because a fouled or poorly maintained cooling tower can reduce the chiller efficiency by 10 to 35%, merely by the fact that we're unable to cool the water to a low temperature, and that can adversely affect the condenser water, the efficiency of the chiller. So overall, cleanliness is a good goal for any water treatment program in any system that operates with heat transfer. Now here's a photograph of a free cooling heat exchanger. When outside air temperatures get low enough, and usually that's below 55 degrees, a free cooling heat exchanger can be used to remove heat from the closed chilled water loop. And here we see the green pipe represents condenser water from the cooling tower. Normally that flows through the condenser section of the chiller, but if we can take the chiller out of service and redirect that water flow through this plate and frame heat exchanger, we can actually cool the chilled water loop by removing heat from the chilled water, passing it into the condenser water, sending it up to the cooling tower, and reject the heat to the atmosphere, and doing all of this without the need for running the mechanical chiller and the electrical consumption that would involve. So it's a very good energy-saving option. So what do we need to know about heat exchangers? First of all, keep everything clean. For good heat transfer, these mineral scale deposits that can form in the condenser and cooling tower can rob you of efficiency by up to 35%. If water side economizers are an option in your particular area, then when outside air temperatures are low enough, the water side economizer can be used to remove heat from the chilled water loop, which offers the opportunity to save a lot of energy. And finally, the mechanical chiller when it's removed from service, by virtue of being able to use a water side economizer, that saves a lot of energy, but not necessarily water, since water is still required in the cooling tower to reject that heat to the atmosphere.